Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate in the Material Science program from the University of Ontario Institute of Technology. I also took my Bachelor's of Science in Pharmaceutical Chemistry at this institution as well. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. So now I'm just going to get started on our set of questions for today's session. Alright, so question number 1 just simply asks, what is the molar mass of sodium hydroxide? Okay, so when you try to find out the molar mass of a compound, we first need to know the atomic masses of the atoms that are involved. For example, for sodium, its molar mass can be found just on the periodic table, and it is just 22.99 grams per mole. We can do the same for oxygen. Its molar mass is around 16 grams per mole. And lastly, for hydrogen, it is the lightest element on the periodic table, and its molar mass is around 1.01 grams per mole. So when we want to calculate the molar mass of NaOH, all we have to do is add these values together with respect to how many atoms there are of each element in the compound. So in the case of NaOH, there is only 1 mole of sodium, 1 mole of oxygen, and 1 mole of hydrogen, so we don't have to worry about multiplying it by any values. So I'm just going to show right here that it's just adding all these values together. Then if you add it all up, the sum of all these values is 39.997 grams per mole. So this is the molar mass of sodium hydroxide. So let's see the answer from our junior tutor. Molar mass is the amount of substance per mole of that substance. Yeah? And molar mass is expressed in grams per mole, or G over mole. First, find out the molar mass of each of the elements involved for sodium, oxygen, and hydrogen. Then get the total. That is the molar mass of sodium hydroxide. Okay, so this solution is correct. Okay, so question number 2 asks, how many cups are there in 1 pint? So to answer this question, we need to know the conversion factor from pints to cups. So in fact, for every 1 pint, there are 2 cups involved. So let's have an example. Let's say, how many cups are in just a random number, 52 pints, let's say. Okay, so to answer this question, whatever value we're looking for will be on the top. So X cups over 52 pints And then I'm going to put on the right side of the equal sign my conversion factor in the same order, cups on the top, and then pints at the bottom. Now all you have to do is solve for x. And you know that you did it right if your units should cancel out nicely. So you'll notice our pints canceling out, and we're left with a value in cups. So this gives us x is equal to 2 times 52, which is 104 cups. So let's see what the junior tutor said. In both the US and imperial system of units, 1 pint is equal to 2 cups. This solution is correct. Okay, so the next question is similar, but this time it is asking how do you convert pints to quarts? So there are actually 2 pints in 1 quart. So now for this example, let me ask, how many quarts are in, let's just say 52 again, 52 pints. I'm gonna first write down the units I'm looking for. So x quarts over 52 pints. And then I'm gonna write my conversion factor on the right side. 1 quart over 2 pints. And now I'll just solve for x. Multiplying both sides by 52. Our units should cancel out. So you'll see here that our pints will cancel out and we're left with a value in quarts. So all it is 52 divided by 2. So there are 26 quarts in 52 pints. So let's see what our junior tutor said. To convert pints to quarts, we need to remember the conversion factor that 1 quart is equal to 2 pints. For example, if I have 50 pints of ice cream, how many quarts do I have? It's a lot of ice cream, but basically you would have 25 quarts of ice cream. So this solution is correct. Okay, so the next question asks, what is a polar molecule? This is a good high school chemistry question. Basically, when you have a polar molecule, this is a molecule with an uneven share of electrons due to differences in electronegativity. So the key word I would say in this definition is that it is an uneven share of electrons due to differences in electronegativity. So let me have an example. I guess I should also add, though, that polar molecules also have a non-zero dipole moment. So this will make more sense when I write out an example of a polar molecule. So a non-zero dipole moment, and this just means that one end is slightly positive and the other end is slightly negative. Sorry, can't spell right now. Slightly negative. Okay, so we'll write down one of the major examples of a polar molecule would just be the molecule of water. So what makes this polar molecule is that oxygen also has 2 lone pairs. If it didn't have any, then it would be a little less polar. But basically, since oxygen has a higher electronegativity than the 2 hydrogens, it has a slightly negative end. And on the hydrogen side of water, it has a slightly positive end. So this is an example of a polar molecule. And I'll also draw an example of what a non-polar molecule is. So a non-polar molecule would be something like methane. So as you can guess, a non-polar molecule is the opposite of a polar molecule. There's an equal share of electrons due to similar electronegativities. So let me just write this down. So this is non-polar. Since carbon and hydrogen, if you were to look up their electronegativity values, they have a similar electronegativity values. So what some people might get confused about is that there's a difference between having a polar molecule and having a molecule that has polar bonds. So for example, let me just box this little corner off. Let's say I had carbon and it had 4 chlorines on it. So as we all know, chlorine is much more electronegative than carbon. So I can draw all of the dipole moments. Well, I mean all of the arrows that signify that chlorine is more electronegative. So the carbon and chlorine bond is a polar bond because chlorine is more electronegative than carbon, but the entire CCl4 molecule is non-polar. So this is because you'll see that they all cancel each other out. Chlorines cancel each other. Yeah. Yeah, so that's all there is to that. Let's see what the junior tutor said. A polar molecule is a molecule whose one end is slightly positive while the other is slightly negative. The absolute value of the difference in electronegativity of two bonded atoms provides an estimate of polarity. When the difference is very small or zero, the bond is covalent and nonpolar. When it is large, the bond is polar, covalent, or ionic. So I'm also gonna add that this solution is correct. Oop. Sorry. Made this full screen. Hello. Okay. Anyways, this solution is correct. So they talk about that difference in electronegativity of two bonded atoms, but the second part of the definition just defines what a polar bond is. The first part is defining the polar molecule. So I'll just kind of clarify that. Okay, so I said that this solution is correct. However, a molecule can have polar bonds, but be a non-polar molecule overall if the dipole moments cancel each other out. And then I just gave my example. But this solution was still correct. And we can move on to question number 5. The density of brass is 8.89 grams per centimeter cubed. What is this in kilograms per meters cubed? So first let's understand the relationship between grams and kilograms. So in 1 kilogram, this is the same as 1,000 grams. And similarly for 1 meters cubed, this is the same thing as 1 times 10 to the 6 centimeters cubed. So let's say we started off with 8.89 grams per centimeter cubed. I would first have to multiply it to get rid of the grams. So first I would put the units I'm looking for on top, which is kilograms over 1,000 grams. I'm just going to show out my grams should cancel out. And what also needs to cancel out are the centimeter cubed. So I'm going to put this at the top instead because the centimeter cubed in the original question is in the denominator. So in order to cancel it out, I need to put it as the numerator. And we're looking to convert it to meters cubed. So again, you'll see centimeters cubed canceling out. And if you were to plug all this into like a calculator, you end up getting 8,890 kilograms per meter cubed. So let's see what our junior tutor said. To answer this, we need to perform dimensional analysis. Recall that 1 kilogram is 1 times 10 to the 3 grams, and 1 meter cubed is 1 times 10 to the 6 centimeter cubed. And they got the same answer. This solution is correct. Okay, so let's look at question number 6. What is a glycosidic bond? So a glycosidic bond, if we first try to analyze the word, you'll notice that it has as a prefix like glyco. So we can kind of relate this to glucose or to sugar molecules in general. So we know that the glycosidic bond has something to do with like sugar. So actually, glycosidic bonds are covalent bonds, or bond, I'll make it singular. It's a covalent bond that joins a sugar molecule to another group. So you're not limited to just sugar molecules binding with another sugar molecule. It can bind to something else as well. So I'm going to show that in an example. For example, let's say you had the following sugar molecule. So all sugars kind of look similar to this, and they just have alcohol groups sticking out. And like depending on the direction of the alcohol groups, like this one is going up, that's what kind of sets them apart. So let's say we had a sugar molecule. I couldn't tell you what this one is actually called, but this is just an example of one. And then I'm going to add just another alcohol group. Let's say this is like ethanol. But it can be really any other group. I'm going to circle where they would connect, ideally. Let me just... here. I'll circle like a water molecule as kind of like a byproduct of this reaction. And then I'll draw our final molecule on the right. And then I'm just going to draw in where the two groups came together. And I'll also be technical and add that water was also produced as a byproduct. And the glycosidic bond in particular is right there. So this is our glycosidic bond. So let's see what our junior tutor said. Glycosidic bonds are covalent bonds that combine monosaccharides or longer sugar chains to other carbohydrates, forming disaccharides, oleosaccharides, and polysaccharides. This solution is correct. Okay, so moving on to question number 7. Question 7 asks, what is a solvent? So, a solvent is a liquid that dissolves a solute to form a solution. So it's funny when you try to find these definitions in a textbook, if you were to look up solvent, they would say something like it's a liquid that dissolves a solute to form a solution. But then if you look at the definition of solute, it's like it's the solid that dissolves in a solvent to form a solution. It's just weird. We just add an example in case you're still having troubles understanding what a solvent is, but basically, let's say we're adding salt to water. I'll draw out like a cup. No, let's make it light blue for this water. And then I'll just draw like salt particles. So in this case, the salt is our solute. And then, as you can guess, our water is the solvent. So there's also a lot of other examples of solvents. And when you start to do more like reactions, you'll notice that some solvents need to be non-polar, some solvents need to be water. So like some examples of solvents are, I'll just put water. You can have like methanol as a solvent, ethanol. So these are all polar solvents. You could have hexane, which is a non-polar solvent. something called dichloromethane is another interesting solvent as well, also known as DCM. Why did I say ethyl? Ethanol. Yeah, so it all just depends on what reaction you're working with. And you also have to be careful because some of these solvents can be toxic to your skin. Like DCM, you need to wear gloves. And always read the MSDS. Yeah, so those are all just different examples of solvents. So it doesn't just involve water. You can have a lot of variety of different solvents as well. Or even like a mixture of two of them. Like 60% water. And 40% methanol. So there's a lot of variation to it, really. So let's see what our junior tutor said. A solution comprises of two components, the solvent and the solute. The solvent is responsible for dissolving the solute to form a solution. In most cases, solvent is in a form of liquid, while the solute is in a form of small solid particles. A classic example of this is when you have your cup of coffee in the morning, you have the coffee powder, which is a solute, and then you pour water into it to have your cup of coffee. Yeah, pretty much. And the water is the solvent where it dissolves the coffee powder. Water is known to be the universal solvent because it can dissolve many types of solvent compared to other solvents. What? Yeah, sure. Yeah. I'd be careful saying that water is the universal solvent because it can't dissolve like some like non-polar materials. Is correct. I'll just kind of add like a footnote. Water is a common solvent, but it is not able to dissolve, let's say, non-polar solutes. In cases like this, a non-polar solvent, such as hexane, can be used. Let me just also add, since like dissolves like. Okay, solution is correct. Let's move on to question number 8. Decomposition reactions blank compounds. I'm also going to write out the sentence. So we have different options. Decomposition reactions never involve compounds, so we know that's wrong. Decompositions explode compounds, so that is not true either. Decomposition reactions break down compounds, so that is actually what we're looking for, but just out of curiosity, let's see the last one. Decomposition reactions build compounds. So that's not true. So the answer is break down. So that makes sense. Most people know what decomposition means. I'll just have an example of like a basic decomposition reaction. Let's say you had AB, it would break apart and form A plus B. Okay, so let's see what our junior tutor said. In a chemical decomposition, a compound is broken down into 2 or more chemical species. Usually, chemical decomposition requires energy input. One example is the decomposition of potassium chlorate to produce oxygen gas. In general, chemical decomposition is represented as AB creates A plus B. To illustrate the example, the decomposition of potassium chlorate, they wrote the symbol wrong, is represented as 2KClO3 makes 2KCl plus 3O2. Yep, so this solution is correct. Okay, so moving on to question number 9. How do you convert centimeters cubed to milliliters? Well, actually, this is one of the simpler conversions you could make because 1 centimeters cubes is equal to 1 milliliter. So let's say you had 100 centimeter cubed. That is equal to 100 mils, and so on, so forth. So in converting centimeter cubed to milliliters, no computation needs to be done because 1 centimeter cubed is equivalent to 1 milliliter. So this is also helpful when you want to measure out like water. Because water is one of those like special compounds that when you have 100 mils of water, this is the same as saying you have 100 grams of it as well. This solution is correct. Okay, so now let's move on to question number 10. What is the formula of nitric acid? So nitric acid is one of those acids that it's helpful to memorize what its structure is. Basically, it is HNO3. So if we were to break it apart into its ions, it would be H plus, and this is a polyatomic ion, and the whole thing is NO3 minus. So if I were to draw out the structure of nitric acid, it would look a little something like this. So let's see what our junior tutor said. Nitric acid consists of 1 hydrogen atom, 1 nitrogen atom, and 3 oxygen atoms. This written in its chemical formula as HNO3. The Lewis dot structure is shown below. All 3 oxygen atoms are bonded to nitrogen, and the hydrogen atom is bonded to 1 oxygen. Yep. So this solution is correct. Okay, so now let's move on to question number 11. How many quarts is equal to 8 cups? So first, let us recall that 1 quart is equal to 4 cups. So if we're looking for quarts, I would define it as X. X quarts over 4 cups. 8 cups. And then on the right side of the equal sign, I'm going to put 1 quart over 4 cups, which is our conversion factor. So you'll notice that the quarts should be on the numerator and our cups should be on the denominator. Then if you do the math and solve for X, so let's multiply both sides by 8 cups. You'll notice that our units should cancel out, and we're left with a value in quarts. So 1/4 times 8 is the same thing as doing 8 divided by 4. So X is equal to 2 quarts. Okay, so let's see what our junior tutor said. To convert cups to quarts, we need to recall the conversion factor. 1 quart is equal to 4 cups. So quart is equal to 8 cups times 1 quart over 4 cups, which is equal to 2 quarts. Thus, there are 2 quarts and 8 cups. So this solution is correct. Okay, so let's look at question number 12. What is the correct formula for sodium phosphate? So let's try to break this apart into what their ions would look like. So for sodium, it is Na+, and phosphate is an example of a polyatomic ion, and its structure is PO4, and it has a 3- charge. So I'm just going to take note that for a neutral compound, we need 3 Na+ ions to neutralize PO4 3-, since Na+ has a +1 charge and PO4 3- has a -3 charge. So the most stable form of sodium phosphate will be written as Na3PO4. So we can also write out its structure since it has a pretty interesting structure. Basically, we have our phosphine, and it has a double bonded oxygen, and then 3 more oxygens, single bonded oxygens that all have that minus charge. And then I'm going to draw out what the sodiums would look like. They're over here, reacting with the negatively charged oxygens. Okay, so that is the structure of sodium phosphate. So let's see what our junior tutor said. The correct formula for sodium phosphate is Na3PO4. This is so since sodium phosphate is an ionic compound and is made up of sodium ions and phosphate ions. This means that as long as we know the formula of the ions, we can determine the formula of the compound by combining them. We must also know the charges of the ions involved. Since a phosphate ion has a charge of -3 and sodium has a charge of +1, 3 sodiums are needed to make a neutral compound. This can be simplified by using the absolute value of the charge of the ion and place it as the subscript of the counter ion. This follows that the sodium ion would have a subscript of 3 from the absolute value of the charge of the phosphate ion, while the phosphate ion would have a subscript of 1 from the absolute value of the charge of the sodium ion. So kind of an odd sentence. While the phosphate ion would have a subscript of 1 from the absolute value of the charge of the sodium ion. Yeah. Thus, Na3PO4 is the formula for sodium phosphate. This solution is correct. Okay, so I think I have one more question lined up. And it is just asking, what is the molar mass of ethanol? Okay, so let's say we don't know the structure of ethanol. Let's try to draw it out. Okay, so we have an eth as the prefix. So this signifies that our parent chain has 2 carbons. And you'll also notice that it ends in -al. So we also know that it contains 1 alcohol group. Since it doesn't end in diol or triol, it's just a plain ethanol. So we know it contains the 1 alcohol group. Okay, so let's write out the parent chain. It will have 2 carbons. And we also know that it contains 1 alcohol. So I'm going to draw it at the end here. Since it doesn't really matter which carbon it's on, we know it'll be on carbon 1 anyways. So we can number it like 1, 2. So it doesn't really matter if it's on the front or in the back. And now, since every carbon atom needs to have 4 bonds attached to it, just because this is an organic compound, we're just going to fill in the places with hydrogens. Okay, so now let's look at the formula for ethanol. There are 2 carbons, so I'm going to write C2. There are 1, 2, 3, 4, 5, 6 hydrogens, and 1 oxygen. But another way of writing this is to do H5OH, just so that we can easily see that there is an alcohol group on this compound. So now that we know the chemical formula for ethanol, we can calculate the molar mass of ethanol. So to do this, first we need the molar mass of carbon. So its value is 12.01 grams per mole. So these are just values you would find on your periodic table. We can do the same thing for hydrogen. Its atomic mass is 1.01 grams per mole. And then finally for oxygen, it has an atomic mass of 15.99 grams per mole. So now, to calculate the molar mass of ethanol, C2H5OH, it's going to be 2 times the molar mass of carbon, since there are 2 carbons in ethanol. It's going to be 6 times the molar mass of hydrogen, since there are 6 hydrogens. And then I'm just going to also write out 1 times the molar mass of oxygen, since we have 1 oxygen. So now let's just plug the values in. 2 times 12.01 grams per mole plus 6 times 1.01 grams per mole plus 15.99 grams per mole. So if we add all these values up, we end up with a total molar mass of 46.07 grams per mole. Okay, so let's see what our junior tutor said. Molar mass is the mass of 1 mole of a substance. To compute for the molar mass of ethanol, one must know its molecular formula. Ethanol may be written in 3 different ways. May be written as CH3CH2OH, C2H5OH, and C2H6O. All of these contain 2 atoms of carbon, 6 atoms of hydrogen, and 1 atom of oxygen. To compute its molar mass, multiply the atomic mass, which can be obtained from the periodic table of elements, of each kind of element with the number of atoms present. The sum of all the products is the molar mass of ethanol in grams per mole. So now let's see, they have carbon 12.0107 times 2 is equal to 24. Hydrogen 1.00784 times 6 is equal to 6.04. Oxygen 15.999 times 1 is equal to 15.999. So the molar mass of ethanol is just adding all the values together, and they also got 46.067 grams per mole. So this solution is correct. Okay, so I think that is all the time that I have for today's session. If you like today's Q&A and you'd like to be notified of when we do this next, then please hit the subscribe button and the notification bell below. If you wanted to submit a question of your own, then check out the links in the description below as well. And if you like today's video, go ahead and give it a thumbs up and a comment, and also don't forget to share it with all your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye!